Hey, welcome to a lesson on information security. In the next 4 videos, we're going to create a virus using the Python language. And so we're going to have 3 parts that will show us how to do self-replicating code. So the code will take itself from one file and duplicate itself into another file. So don't worry, we're not going to infect your entire computer. We're just going to be infecting Python scripts in the same folder. So very localized. The second is we are going to try to scan and detect which files have been infected. And so we'll use a technique that many virus programs use called virus signatures. In real life, there are thousands of virus signatures that a virus program has to keep up to date. In our example, we're going to have exactly one virus that we're looking for. But we'll use virus signatures as a strategy to find and remove the virus. The third is we're going to use a method called heuristics, which is a big word that simply is involved with changing of data of a file. So we'll look at the size of the file, the number of bytes that it occupies on the disk, and also the date in which it was last modified. And so we'll detect changes to see when the infection occurred, and then we'll be able to give an alert to our users of where the infection is. Lastly, I would like to tell you that this is not a real virus. What we're making is just a program that modifies text files. So there's no executable files involved here. There's no pranks that you can play on your friends. But it does use some of the same strategies and ideas that you would find in a real virus, and then also the virus scanning software. So the purpose here is education, so you can see how viruses work. Now, in the real world, viruses are much more complicated than what we're going to make. Ours is plain text. There's no encryption. There's no sense to hide the virus from other people. But it does show us some of the programming strategies that a real virus maker would probably have to think about. Hello. In this video, we're going to create a virus in Python that will show you how a piece of code can replicate itself, execute itself in other positions, in other places, and spread around on your computer. The second part of the video is we're going to take another Python program and we're going to detect any changes that were made in our scripts and detect the infections that our original virus made. This is not a real virus. This is a Python script that only affects other Python scripts, and so it really isn't what you're looking for if you're trying to hack somebody or spread malicious code. But it is a good demonstration of how code can duplicate itself and execute unexpectedly. So let's take a look at how this program works here. You can see on the screen that I have a directory open that has 2 Hello World programs. Let's open those and see what they look like. So you can see, by the way, that I'm using the program called idle. Idle is the most basic code editor that you can get, an executor of Python. So if you want to download the Python idle editor, you can get it at the official website python.org/downloads. When you download Python, you will not only get the runtime to make Python work on your computer, but you will also get this editor that will write and run code. A lot of programmers that work with Python would work with more advanced editors, like maybe they would use PyCharm or they would use Visual Studio Code. But we're just going to use the most basic of the editors because that's what you get when you install Python with the default packages. Well, you can see that the first program that I've created is the simple print hello world. That's the nice thing about Python. You have one line of code, and if you go to the run command and choose run module, you will see that it shows the blue text here, hello world. So it seems to be working there. Let's open up the other. It's called hello again. And the point of these 2 scripts is to demonstrate that the virus code that we're going to write will infect these files. So if I run this thing here, I should get 2 different statements, and there they are, hello world and hello again. All right, so let's go look at our Python virus code. That's what's open on the screen here. And this is the code that is going to run and copy itself into all other Python scripts in this directory. So I'm limiting the infection to one folder. It's not going to ruin your whole computer, so you can be safe with that. So I'm going to run this module now, and it will say it infected a file. And you can see on the screen here that the icon in Macintosh shows the preview of the contents of the file. Let's see what's inside hello now. And you can see that the original hello world was here, and the copy of the code itself is inside of here. So this is a pretty easy program to disinfect. You just say, what are all these stupid lines here? I'm gonna highlight them and get rid of them. Okay, so I have disinfected this file. However, if somebody comes along and they run this file, which is hello again, and they run it, it should infect other code on the program as well. So the code is replicating itself across all other scripts in the folder. And so that's what we're going to build by the end of this video. So the first thing I'm going to do is delete all the folders, all the files that are in this folder here, and we'll start from scratch. So let's go to our idle program here and start a new file. So let's go to New File, and let's start working on our virus. All right, before I do anything else, I'm going to save this code here. So let's go to Save under the File menu. So I created a folder called Python Virus, and I'm going to put in here Python Virus as the file name and .py for the extension. Okay, so you can see I have a new file in my folder. The first thing I want to do is create a comment that starts the virus code and ends the virus code. We're going to use this in our script to be able to figure out where the beginning and ending of the code is, obviously. The first thing I want to do is to take a copy of everything that you see between the starting point and the ending point and save it into a list. So I'm going to create a list called virus code, and this will save all the lines that are currently on the screen. The next step is I'm going to open up the file that I'm currently in, my own self, and I'm going to read all the lines that are in it. So then I want to filter out all the lines that are not inside the virus code boundary. Now I want to capture the file name. And so in Python, the sys.argv array is a list of things that are passed into every program. And the first parameter, or the first argument given to a program, is the actual file name of the program itself. So I'll set a variable called virus file, and this will open up this file, and it will open it up as a read-only file. So let's call the function called readLines, and let's save all those lines into a list called lines. Okay, so now let's do a test to see if we're actually reading the lines, and we'll print them onto the screen. This would be a good time to save it and to run the code. As you can see, when I run the code, there's an error. It says the name sys is not defined. And so this here, this sys arguments doesn't work. So what we need to do next is add a include. So we need to add the system modules, and let's see if this will run better now. Okay, so you can see that the code is designed to read itself and print it out into the screen as a list. Okay, so that seems to work. I'm going to delete this testing line now. We know that it's reading the file correctly. So in the next part of this program, I'm going to try to save all of these lines into a list, and I will use this list later to insert into other code. So I'm going to create a variable that's a Boolean, and I will make it a flag to say, are we in the virus section? And we'll initially set it to false. Then I'm going to go through each line that I read, and I'm going to do a test on it to see if we come to the part called the starting virus code. Now, to be able to check to see if I've reached this line, I want to do a string matching pattern. So I'm going to use a regular expression library. So I'm going to say re-search, and I'm going to search for a string here. Now, RE is something that I have to import as well. So let's go up to the top and put in a import RE. That stands for regular expressions. Now, the expression that I'm searching for is this code at the beginning. So let's just copy that and paste it into here. Now, I want to be very careful to say that I want this to be a caret at the beginning to say we're going to search, and it has to match the very first entry in the line. So I don't want to match this string if it's not the first character in the line. There's two parameters for the search, and we need to say that the second parameter is the string that we're looking for. So this is a string inside of the lines. So now if we have found this string, then we can confidently say that we are now inside the virus code. So I will set the Boolean in virus to equal to be true. All right, some more comments now to say what we're going to do next. We're going to put in the comments to say if the virus code has been found, if we have reached this section, then start appending the lines to the virus code list. So this virus code list initially started off as an empty list. And then we will just build this list as we go down. Now we assume that the virus code is usually appended at the end of the script. So to implement this, we have to have an if statement. So if we are inside of the virus, then we will append the line to the list called virus code. All right, the next search we want to do is to see if we've reached the end of the list. So I'm going to do another regular expression search, and the search string that we're looking for is the code here, this comment at the bottom. So let's copy the end of virus code and place it inside of our search string. So I'll put in the caret to begin the search line as well. Also, we need to tell it which string we're looking for, which is called line. All right, so if we have reached the end of the code, then we will break out of this for loop. So we'll put in the word break. Okay, so all of this code here was done just to save all the lines of the virus code into a list. And the list is called virus code. All right, the next section down is we're going to find potential victims that we can infect. So the next command that I'm going to use is called glob. And we need to import this as a part of another module that is extending Python. But glob is very handy. It will take a pattern match and search for all programs inside of our folder. And so we're going to only search for anything with a py extension. That's the only victims that we can infect. So since we're using glob, let's go up to the top of the import section and add glob there. So the next thing I need to do is to check and infect all of the programs that glob found for us. So we'll make a for loop. We're going to do a for loop for all programs that were listed. So we'll call each iterator a p. Now we want to open up p as a read-only file. And then we will save all of the lines that came from that file into a list called program code. After we have read all the lines, I'm going to check to see if this code has already been infected. So we will assume that this program is not infected yet, so we'll set the Boolean flag to false. Now we're going to go for each line in the program code. And we want to search for that specific line that tells us that we have already found the infected code. And if it's already there, then let's set it to our variable called infected to set to be true. So as we used before, we have a special string that we know we can search for to tell us if that is in our code, we know it's infected. So if we find the string, then we will stop. We will do a break. And that will break out of the for loop, and we don't need to infect this program again. So the interesting thing now happens if we are not infected. What we're going to do is create a new list called new code. And this will be a concatenation. So the new version, our new code, is going to be the current code that we have in our script, plus we'll tack on the virus code at the end. And so the infection just is an append operation to add more lines to the code. So the first assignment we can do is simply say that the new code is equal to the program code. Now remember, program code is what we just read into the file, or from the file. So whatever was in there, we will make into the new code. However, we want to extend the new code, so the extend operation will concatenate the two lists. So now we have a new code. We want to write this back to the file, overwriting the original version of our script. So we'll open up a file. Remember, the file name is called p, and we will open it up as a write permission. So the write lines is the command we're looking for, and we want to write new code into our file, and then we'll close the file. So the whole point of a virus is to be able to do something, and usually that's called the payload. So our payload is where we do our evil work. You can imagine that you could delete files, you could copy things, you could do key logging, you could do all kinds of password sniffing. In our case, this is a very uninteresting virus. The only payload we're going to do is print a graffiti message on the screen that says that this file is infected. Let's go to the end now, and we are going to delete the code. So this should all infect another file. Let's see if it actually does work. I'm going to make a new file and make hello world, and let's see if it works. So hello world is created. Let's save it, and I'm going to call this thing hello py, and we'll close it. Okay, so we have the virus here, and we have the victim here. Now let's see if I made any typos. Let's run the module and see what happens. So it says this file is infected. Let's close the terminal. And it looks like hello is now filled with a virus code. So you can see the original line was one line, and now we have all of this code that goes all the way to the end. Let's close it. Let's make another version of our program. We'll call it hello, and let's print a couple of things on it. Let's save, and let's call this hello again, and name it .py. Okay, so this one here is the clear, uninfected version. Python has infected, our Python virus has infected hello. Let's open up hello and run hello, and let's see what the results are. So it does print hello world, and then it says this file has been infected. If I close this and this, you can see now that hello world again has now picked up the code. So it was originally programmed in our virus file, it's spread to hello, and now it is spread to hello again. So our virus seems to be replicating. Now, the next part we need to do is to be able to detect changes and pretend that we are a virus scanner. So remember, the point of this lesson is not to learn how to do malware, but to detect it and understand what viruses are trying to do. Hello and welcome back to our virus scanning demonstrations here. In the previous video that I made in this series, we had a virus that was able to infect other files. And so you can see on the screen the results of that program. So this is a virus that is able to copy itself into other Python scripts. So it's not a real virus. It doesn't affect any of the executable programs on your computer, but it does affect other Python files. I'll give you a quick demonstration just to see what it does, and then we'll create a virus scanner. So this thing here just ran, and as you can see from our programs here, hello used to just have a single line of text in it. So let's disinfect this one file here. I'm just going to highlight all this code that was inserted and go back to our original Hello World app. Now the next goal that I'm going to do is create two separate programs that will scan for viruses and alert the user that they're infected. First of all, we'll use what's called a virus signature program. This is simple. All it does is it looks for the pattern of the virus in the program, and if it finds it, it alerts the person. The second is a heuristic kind of a check. It will see if the file size and the file date of the program has changed, which is also a great way to identify a virus has infected you. So we'll probably save that one for the next video. In this video, we're going to create the virus signature scanner. So just out of curiosity, I went to find what Symantec has for their signatures. As you might guess, they have a lot of them. And so if I were to browse through here, it says they have 1,094 of signatures. You can see that every virus that's been discovered, or been created, I might say, has a name to it, and there's different version numbers. And the goal of Symantec in one of their scans is to look for any of these patterns. So if we were to find a kill and look at its code, you would see that there would be a signature to it. There would be unique code that is in this program that is not in any other programs. And so they just simply scan all executables and DLLs and to see if there's any sign of that code. So that's what we're going to do in this video, is create signature scanners. So in this example, I have an uninfected file, hello, and an infected file, hello again. And when we run our scanner, it should tell us that one of these is clean and the other one is clear. So I'm going to go into idle and create a new file and start with my virus scanner. So in the first part of my program, I'm going to create a scan the signature kind of a program. So just like a Symantec or other programs will search all files and look for specific types of code. So I'm going to create a function called check for signatures. And the first thing I'll do is print to the screen what I'm doing. So when I create my report, I will have a beginning and an ending line for telling what's going on. So the first thing I want to do is check for every Python file in this folder. And so I'm going to use the globe library again and look for the pattern match that's star.py. So since we're using glob or globe, I'm going to import it up near the top of the program. So after I get a list of programs, I'm going to loop through each one of them. So I'll use a for loop using p as the counter variable, and then we'll initially set the value of this file is infected. We'll set it to false until we find the signature. In the next 3 lines, we will open the file, and we will open it with read-only access. And then we will save all the contents into a list called lines. And then finally, we get to close the program. So now we'll go through each line in the file. And we'll say for a loop, line in lines. And then if we find a signature in one of the lines, then we know we have found a virus. So since we're using the regular expression library here, we will also import that near the top. So we will put import RE. Now the signature that I'm looking for is a specific item in my virus that I know should be there if it's infected. Well, let's go back to the part of the code here. So we could probably select a block of code that would be somewhat, unique to the program. Just for ease of use, we know that the line here called end of virus or the line called starting virus code is unique to this program. So I'm going to copy that and use that as my signature. So if this appears anywhere in the program, then we can assume that the file is infected. So if we do find a virus signature, we will print out a large warning that says virus found in file P. And then we will set the boolean of the this file is infected to be true. After the for loop is finished, we can check to see if this file infected is still false. So if it never got changed to true, then it appears that this file is clean, and so we will print a nice message to the user telling them that that file is clear. Now after the program is completed, we need to actually call the function. So at the very bottom, I'm going to call the function we made called check for signatures. So I'm going to save this and make sure that I'm still in the same directory, and we'll call it virus scan. How about? Okay, so now this should be able to tell us about all of the other files in the folder. Let's see what happens when I run it. So I run the module. Uh-oh, we have a syntax problem. What did I do wrong? Let's see, it looks like I forgot an extra parentheses, so you'll probably end up doing some of the same things that I am, checking for your typos. Okay, this time we have a report. Okay, so let's compare the report to what we know is to be true. So hello PY appears to be clean, and if we look at this, it looks pretty clear. I've only got one line of text. It says hello again is infected. Python virus obviously is infected, and it scanned itself, and it said virus scan appears to be clean. So this is the virus pattern matching method. So in the next video, we'll use a more common method called the heuristics method to check to see if file size changes and date stamps have also been changed. So another common tool that will help you understand how virus scanners work. Now, had this been a real virus scanning program, we would have to search for far more than just one line of text. We would probably have to create a library of thousands of signatures and check each one of them against each file. And so the virus scanning process on your computer likely takes several minutes because there's a lot of pattern matching going on. But in this case, it's a single line of text, and it demonstrates the basic idea of how to scan for a virus signature. Hello. In this video, we're going to do another virus scan program. In the previous video, we were able to scan for virus signatures, and so we concluded that if we could find this line anywhere in a script, we would assume that our virus was infected. If you haven't seen the previous videos, this is a video that simulates a virus infection just using Python scripts. So go back if you haven't seen how the virus works. So the first check that we did was for signatures. In this video, we're going to use what's called heuristic scanning, which will check the file size, we'll check the date, and see if there's been any changes since the file was created. So let's get started with our new scanning program. So I'm going to insert some code down here after the first function, and we'll insert here called a new definition or a new function. Okay, so the comments on my program are to get the initial file size and the date of the program. And then I want to save them all to a text file for use on a later scan. So let's go ahead and collect all of the PY files that are in the directory, and we'll save it in a list called programs. Then I'm going to make a list of data of each program. So we're going to call it program list. Each line will contain 3 items. It'll have the file name, it'll have the file size, and the file date modified. So we'll go through and make those collections right now. So each P in programs is our for loop. So the first thing we already have is the program name. That's stored in the variable p. However, we want to grab the program size and the program modified. And I did a little research to find out how Python does that. With Google searching, you're able to find out that there is a library called OS. And you can simply choose the word path dot get size and then the file name. Now, to be able to use OS properly, we have to import it. So let's go to the top of our imports again, and I'll add OS to my list of imports. So now I can use OS path get size, and I know how many bytes this file size is. So also in the OS library, there is a method that we can use that'll get the modified time. So os.path.getMtime with the variable called p inside. So size will be an integer, I believe, that tells me how many bytes this file is. Also, the modified will give me a number. The number of seconds that has elapsed since the beginning of the Unix epoch, which I think was the January 1st of 1970. So you're just going to get a large integer with millions of seconds since that time. However, every second since then is a unique number, so it works for a timestamp. So I want to save 3 items into a list. The list is called program data. And so it's the file name, the file size, and the date that it was modified. Now I'm constructing a list called program list, and so I want to simply append this list of program data. So this will be a list of lists. Now when I'm finished, I'm just going to return the program list. So this is a helper function. It will be used by other functions to be able to collect a list of data on all the files. So now I'm going to actually put this function to use. I'm going to use it as a helper function to a new function. So the new function is going to be called write file data, and its purpose is to do an initial scan and save the results to a text file. So I'm going to call get file data and then pass it in as a parameter to another function. Well, let's make the other function now. So the function obviously has to be named this. It's called write file data. And the list that it's expecting is a list of programs. So the data that this function generates will be passed in, and then we'll save it to a file. So we'll use the with statement. So with, or while the file is being opened, we will specify the file name here and then create the W tag, which means it's going to be opened with a write access. So I'm going to introduce another library. So I did some research, and there is a library called CSV. You can find it online if you Google it, and it is a writer that will take a text file and print it with a CSV styling. So let's do an import up here with CSV, and then I'll show you how it works. So down here we have a new object, and it's going to be set to be equal to something I'll call WR, which is writer. Okay, so WR is a new writer, and it will be writing to this file. Now it's as simple as doing this, as saying wr.writeRows, and then we'll tell it to use the programs that have been passed in through the parameter. Okay, so let's see if this thing works. I'm going to save it, and I'm going to run the program now. So it's giving us output from check for virus signatures. That was this function down here. This one here actually didn't have any print statements, so we don't see anything on the screen. What do we have though? We have a new file called filedata.txt. That's the file name that I chose here. And let's see what it wrote. Let's see, we need to bring up the size. So now you can see the results of our file. We have 4 different file names. We have the second column, which is the number of bytes, and then the last item is the number of seconds that gives us the timestamp for this file. Let's check to see if this is accurate. I'm going to go back and look at the details of my program and check to see what it says on the other items. So for file size, hello.py is 21 bytes, and we have a 21 listed here. The other ones are listed as hello again is 2 kilobytes, which is rounded off obviously. This is 1,674 bytes. And then the virus scan itself is also listed. So we have ourselves an initial scan for our file. Now there's one other issue here that I'd like to correct, is that every time we run our virus scan, this will create a new copy of our text file. So this will be overwritten. So I'd like to check to see if this already has been done. The initial scan only needs to be done once. So let's put in some new text here in the statement right before the open file for writing. So I want to check to see if this pathway exists, if this file exists. If it does, then we will just do a return statement. So return will exit the function and it won't do anything more. However, that's kind of like an else statement now. So if the else part comes, then it'll continue to write. So let's check to see if this works. So right now I have data that tells me that hello 21 is the first line of data. So you can see it's 21 bytes. Well, let's go in and modify hello and put in some more stuff. So I'm going to put in a few more bytes in the center and save the changes. So now what are the bytes? It says 34 bytes. If we run the program again and it checks to see if everything's good, let's see what happens now. So if I say we have 34 bytes and we have originally 21 still printed, so it did not overwrite the original text file. Let's throw away the text file and run the program again to see if it recreates it for us. And it should. Okay, we'll close here. And the text file now says that hello is 34 bytes long. So that matches here. Okay, so it appears that this only works the first time we run the program. After that, it won't create this text file twice. Okay, so now we have this text file created. It's time to use it to check to see if any changes have been made since the initial scan. And that's what we'll do next. All right, it's time to make a new function. I'm going to call it check for changes. And then I will print out a message to the terminal so we can see what's going on here. It'll tell us we're checking for heuristic changes. And then once again at the end of the function, I'm going to tell it I'm finished checking for changes. So here's the strategy. I want to open up the text file that we created in the first scan and now compare each line in that file to the current size and date of the files that are in the directory. And if we find a change, then we know we've probably been infected by a virus. So a way to get all the lines out of a text file like this is to use a file reader again. And we will take a function called file.read and we'll use split lines. So this will cut up all the lines into individual items in a list. All right, so the next part's a little tricky. We need to convert a list of text items into an actual list. So I want to take the original file list and make it just an empty set. And then for each item in the file list, we're going to split them. So each line will be split by a comma delimiter. And then so the items will be the name, the file size, and the date. So the original file list of the files in the original scan, we'll call it, is going to be stored in this array here. Okay, so the next goal is we have to go get the current data from the directory as it is now, and then we can compare the two lists. So I want to get a current file list. Where am I going to get that from? Well, fortunately, we created the function up here called getFileData. So I can simply just call this function down in this other place right here. So this will return a list of what currently exists in our directory. So the goal now is to compare the old items against the current items and see if there are any differences between the two. So we're going to have to use a double for loop again. I want to go through each file in the current list and to see if it exists in the original lists. And so it's like a for inside a for. So now we can check to see if item 0 in each list is the same. So if the current 0 is equal to the original 0, then we know that the file names match. If the file names match, then we can go on and check to see if the other items match. So the first check we're going to see is if the file sizes match. Remember, the item in the second column is the file size, and we want to double check to see if one is equal to the other. Now I believe that we have a problem that in one file format the file size was saved as a string and the other one was saved as an integer. So I'm just going to make sure that I'm comparing strings to strings. So string of one compared to the string of the other. So while I'm doing the if statement, I'm also going to check to see if the other items do not match. So you might recall that the second item, or I guess this would be item 3 in the list, is the stamp of the date. So we'll also check to see if these strings are equal to each other. So in my comments, I will also update to say file sizes or dates do not match. So I'm going to print out a big alert that says, alert, file mismatch. And I'm going to use a new line character so we can skip a few spaces. So since there is a mismatch, let's just print out the original list of what the current status is compared to the original status. So we'll print a string of C and a string of O. Okay, the last step is to say if everything matches, there's no problems, then we'll just say file appears to be unchanged. Okay, so the last thing we have to do is actually call this function. So down here after check for signatures, we're going to call this new function which is called check for changes. So I'll call that down at the last. Okay, let's save it and run it and see if we have any issues with our file sizes. Okay, I have a syntax error. Let's see what's going on up here. On this line here, oops, I put the parentheses in the wrong spot. So let's try that one there. So now we have open with the file name here. Okay, let's save that and try again. Let's see if there's any more errors. I certainly have the errors. Okay, so what did I do here? So I forgot my colon at the end of the if statement, so we'll put that in and run it again. Now what? Down here at the bottom, I put in an extra colon. So you're seeing lots of syntax errors, and eventually this thing should run. Okay, here we go. So the check for heuristics section is now being printed. It says here, hello appears to be unchanged, hello again is unchanged, Python virus, and it thinks that virus scan has been modified some way because we've been updating it. So it grew in size. The current value is bigger than the original. So is this infected as a virus? Well, no, this has been just modified by the user. So it's clean. In the case of if we were to infect our programs, then we should see a new change. So I'd like to take out this virus scan out of the folder. So virus scan we're going to leave outside on the desktop for now. And then let's go run the Python virus again. And let's see if we can infect everybody. So we'll run and run the module. Okay, so now we've infected all the other files in here. Let's take a look here, and we should see that hello now has a bunch of code, and so does hello again. All right, so let's bring in virus scan back into our desktop area, and we'll run it. And what do we get for a report? We should see a new item. So now the signatures say that hello has been affected, hello again, and Python virus, they're all infected. However, virus scan appears to be clean. That's good. It wasn't in the folder where it could get infected. And now the heuristics run. It says file mismatch. So it looks like hello was infected. You can see the difference in file size. This is 1672, and originally it was only 34 bytes. And so that is a file heuristics. Very simple. It just checks to see if any changes were made. Now the key point here is that in most programming tools, like if you're making a C# program and building a Windows app, the executable file is compiled, and it should never change its file size or file date. And so if one of those items does change, then a virus scanning software, such as Symantec, would be able to check that and not even know which virus it was that infected it. But it just knows that it changed its size. And so this is a second example of how a virus scan system would work. So in summary, we've created a virus program that will infect other files. Then we created a check for signatures program to check to see if a specific virus has been found. And then we chose this last item, which is heuristics, to check for changes in our files. And so those are ways that you can understand how real viruses are built and how they are detected.